Welcome to this video in the R Analytics course. In this video, we will look at the Corrplot and Corrgram packages. These packages are used extensively for correlation analysis and graphical representation for the same. We have talked about the concept of correlation in an earlier video. Here, we will see how in R we can use these packages to graphically represent a correlation matrix for analysis purpose. Both these packages are very similar in their functioning and syntax. Let us first look at the Corrplot package. There are four main components in this: method, type or layout, order, and color. Method tells R that which geometric object we want to use to represent the correlation matrix. There are 7 options in methods, namely circle, square, pie, shade, ellipse, number, and color. Say we select circle, then it tells R to represent the correlation matrix through a circle. Second in line is type. This tells us about the layout of the graph. When we look at the matrix, it can be divided into an upper triangle and a lower triangle. So in layout, we can specify if we want the graph to show us the full matrix, the upper portion, or only the lower portion. In a correlation matrix, the upper and lower triangles will be exact mirror images of one another. We then move to order. This tells us the order in which the display will be done. The 4 options here are AOE, FPC, HClust, and alphabet. AOE stands for angular order of the eigenvectors. This orders the factors in the correlation matrix based on these values. FPC stands for first principal component. It orders based on the first principal component. HClust stands for hierarchical clustering. This clusters the variables on the basis of hierarchy. This will cluster the factors with similar degrees of correlation together to suggest some pattern or trend. Alphabet orders the factors alphabetically. Ordering is important to help us gauge trends or patterns hidden in the correlation matrix, especially if we have many variables. Last argument we have is color. We can use this component along with the previous 3. Say, if we want to specify the color of the squares in the first argument, or if we want to split the upper and lower triangles in the type argument with different colors, then this comes in handy. These are the main components of Corrplot. Let us now come to R. We need to install this package first. Since we have it installed in our system, we will activate the package through the library command. We activate the Corrgram package too. To use these packages, we import a dataset. The name of the file we import is medical. We have seen this method of importing in an earlier video. The columns in this table are customer ID, age, height, weight, diastolic pressure, systolic pressure, and cholesterol. Diastolic pressure tells you the pressure of the body in between heartbeats, and systolic pressure is when the arteries are contracting. We want to find the correlation between all these variables. In theory, there seems to be a relationship between these variables, but what is the magnitude of the relationship is something that we want to know. First up, we remove the customer ID from this table. To do this, we write medical equal to medical open square brackets, comma, and then -1. Since we have written nothing before the comma, it will take all the rows, but it will exclude column 1, which is customer ID. We can check for the revised table. Currently, this table is stored as a data frame in R. Both Corrplot and Corrgram take input in the matrix form. For that, we write medical is equal to as.matrix medical. This helps us convert medical from a data frame to the matrix format. We execute medical to see that now it has become a matrix with the row numbers listed in the first column from the left. Now we will create the correlation matrix of this data set and store it in data1. For that, we use the function cor. Let us first see how the cor function is used. We want to take out the correlation between height and weight through this function. We first extract columns 2 and 3 from the medical table and store it in a variable x. We then convert x into the matrix form. Now that we have matrix of height and weight, we get the correlation between these two by writing cor of x. In the console, we can see we get a 2 by 2 matrix. The correlation between these two variables is 0.3139. Now it has come as a matrix, but what if we want to show it through a graph? This is where the Corrplot package comes to use. Let us first get the correlation matrix for the whole data of medical. Please remember to convert the medical dataset into a matrix form. Now we write data1 equal to cor of medical. Therefore, we have stored the correlation matrix for all the factors in medical in a variable named data1. Since there are 6 variables, this will be a 6 by 6 matrix. To check for it, we execute data1 and get the output in the console. We can see that the variables are in the same order as they were in the table, and the diagonal is 1, which was as expected. Please remember that the value for correlation will be between -1 and 1. Upon looking at it closely, we see that the upper triangle, which are the values above the principal diagonal, are just a mirror image of the lower triangle. By default, we get the method as number type. Now we will use the Corrplot package to visualize this matrix. We write Corrplot, then we mention the name of the variable, which is data1. Then we mention the method and put it equal to circle. Please remember the list of methods available to us was circle, square, pie, shade, ellipse, number, and color. The moment we press Ctrl plus Enter, we can see that the plot is there on the bottom right. We can see that the correlation matrix is represented through circles over here. We can see that the size of the circle reduces as the correlation gets close to 0. The correlation between age and height is around 0.4, so the circle is smaller than the one for height and height, which is 1. Age against weight is -0.6, so the circle is again bigger than 0.4. Therefore, as we close in towards 0 from -1 or 1, the size of the circle becomes smaller. We can see for different values over here in the matrix that how the size of the circle changes. On the right hand side, we can see the color scale. Blue denotes 1 and shades of red denote negative correlation. Dark blue to light blue to white shows we come from 1 towards 0. And then from white to light red to dark red denotes a movement from 0 to -1. Let us change the method to square. We can see that the only change in the graph is that of the shape. Rest of the things, color, size, etc. remain the same. We now change it to pi. This one is pretty interesting. Full blue circles denote a value of 1. No circle denotes 0. When the correlation is positive, it is in blue, and it starts filling the pi in a clockwise method. The negative ones are like age and weight are in red, and they start filling anti-clockwise. The third one in the first column shows a strong negative correlation between age and weight, whereas the correlation between diastolic and systolic is a strong positive one around 0.66. We can keep changing the methods to see the output for each and every one of them. When we put number, it shows us the same matrix as the one in the console but with some colors. The last one is color. Now we move to type argument. By default, we saw R was taking the full type. We write Corrplot, data1 and type is equal to full. We can see we get the same plot as we did when we put method equal to circle. So by default, type is full and method is circle. Full type displays the whole correlation matrix in the plot. We change the type to upper now. This gives us the plot of the upper triangle of the correlation matrix. Similarly, if we write lower, the upper one becomes blank. Thus, type helps us determine the layout of the plot. We will now use method and type together. So we write corrplot.mixed data1 lower equal to number and upper equal to circle. So what we basically have done is specified to R that the lower part of the matrix should be displayed in the numeric form, whereas the upper portion should be represented through circles. This is why we used corrplot.mixed, since we wanted to use different methods for different parts of the plot. As we press Ctrl plus Enter, we can see that the desired output is achieved. Now we will try and specify the different color we want in our plot. We change the lower type to shade. As we can see, we get colors ranging from red to blue. But what if we want blue color in the lower triangle and green in the upper one? Then we add two more arguments specifying the colors for both the lower and upper triangles. Upon execution, we can see we get the appropriate colors. We can keep changing the methods, colors and types to have a look at various plots. We would urge you to practice as many combinations as possible. Here we have blue pies in the lower triangle and green circles in the upper one. We can also color the background. Say we use an earlier code of method equal to pi. We then add another argument where we write bg equal to cyan, where bg is background. We can see that the background of the plot has been colored. Next up, we see how we can play with the text mentioned in the plot. We write Corrplot, data1, lower equal to pi, upper equal to ellipse, and the text color, which is written as tl.color equal to blue. As we execute this command, we can see that the names of the variables are now coming in blue color. TL stands for text label. We can change the alignment of the way the text is written by using an option in Corrplot. We write tl.srt equal to 45. This rotates the text to 45 degrees. This is how we can use different things in Corrplot to format our plot as per our requirements. Next up, we look at ordering. Remember, ordering helps us get the hidden patterns or trends in a Corrplot. So we write Corrplot, data1, upper equal to circle and lower equal to number. As we execute it, we get an error because we had to use corrplot.mixed and not corrplot. Now we get the required output with numbers in the lower triangle and circles in the upper one. Now we want to order this matrix. We write order equal to AOE. The moment we execute this, we can see that now cholesterol comes first, then age, followed by systolic, and so on. This is because now R is ordering the factors based on angular order of eigenvectors. We would request you to look up some statistical readings to know more about eigenvectors. Next option is FPC, first principal component. The order has again changed, with height coming first, followed by weight and cholesterol. This is basically the principal component analysis method. The next option is alphabet, which is also the by default setting. It arranges the variables from A to Z. Lastly, we have hclust. This basically gives the order based on clusters. We have some more options in hclust. We write Corrplot, data1, and then order equal to hclust. Then we write addRect, which tells R how many rectangles should be added. Say we put it equal to 2. We can see that it has clustered the variables into two major rectangles. If we change it to 3, there will be 3 clusters it will prepare. We can use different colors here. For that, we create a color palette. We write mycol equal to color ramp palette. This function in R helps us create our own color palette. We input colors red, orange, and blue. Now in our command, we write col equal to mycol and in brackets 3, which says how many colors to be used in our clusters. Had we put 1, then all the circles would have been red. We can keep changing these options to see different plots. We can change the background color as seen earlier. We can also change the color of the text using tl.col. These are the various methods and techniques used in Corrplot. Let us now look at Corrgram. There is a minor difference in syntax. The major difference is that methods in Corrplot is known as panel in Corrgram. So we write Corrgram data1. Order will be either true or false. Then comes panel, which is the geom object. Then we state the lower and upper panels, and then the text and diagonal panels. This is the basic syntax of a Corrgram. Order equal to true lets the variables be ordered based on principal component analysis. Let us write the command now in R. Corrgram followed by data1, order equal to true. In Corrgram, we have 4 types of panel: pie, shade, ellipse, and PTS, which is scatter plot. We write lower panel equal to panel.shade, upper panel equal to panel.pie. Text panel, we put it equal to panel.txt. We execute this command now to get a similar plot as before. To remove the lower or upper panel, we can put it equal to null. This is it for this video. We would request you to practice with various options for these packages to get more and more attractive graphs. Thank you.